Welcome to another Swift Coding episode. Today we're going to be learning about the potential of a circuit. Now, you might have heard the name in physics, potential energy or kinetic energy. That also applies to electrical circuits. We can have the potential of a circuit, and essentially that potential is the voltage, but we're going to talk about potential energy, what it is, and how it relates to circuits. So first we need to understand potential energy and kinetic energy. So here we can write PE and KE. Kinetic energy, potential energy. How about we have a graph, and we have little hills, and it goes up and down. And here is the potential energy, and here is the kinetic. Here is the kinetic energy. Say a ball is rolling up and down these hills. It's going up and down. When the ball is at this point, it has a lot of potential energy that has the potential to be released. It could be released with just a little bit of force. It rolls down the hill and releases all of that potential energy by going down the hill. When the ball is down here, or when the ball is here or here, it has high kinetic energy because it's rolling down and it's moving a lot. And kinetic energy is essentially the energy that is being generated from moving. These are both theoretical. And there is a rule for potential energy, a mathematical equation. Potential energy equals mgh. G is probably always going to be the same, depending on what planetary body you're doing calculations on. But here for Earth, G is constant, and it is 9.81 meters per second squared. So gravity for Earth is constantly 9.81 meters per second squared. Height, say we're on a hill. The height at this point is a lot higher than the height at this point. So as the height increases, potential energy increases. As gravity increases, potential energy increases. Now, M is the mass, and mass affects potential energy because mass is essentially how hard it is to accelerate an object. Say we have two balls of the same size. One is metal and one is wooden. We can assume that the metal ball, or if we're given a value, the metal ball would most probably be the one with the higher mass, and the wooden ball would have a less mass. So it is actually easier to pick up a wooden ball and throw it than it is to hold a metal ball and throw it to the same distance. So as mass increases, the harder it will fall down the hill, thus increasing the amount of potential energy it has at the top. So now you might be wondering, what does this have to do with anything relating voltage? Well, let's talk about electrons again. In the atom, there's a little nucleus with protons and neutrons, and around it are energy levels, sometimes 4 or 5 or 2 or 1 or 3. Say we have an electron here. It revolves around sort of like the universe, but in quantum mechanics, electrons don't really behave like the solar system because electrons can't exist anywhere between these energy levels. They can only exist on one energy level, so they're not really that similar to solar systems, but the way they revolve around the nucleus is similar. Say we have a mountain, a snowy mountain, and if we put a ball on top of it, that ball has a lot of potential energy. Let's say that the ball is an electron, and there is a wire that goes up and then down and then back. Say we have like a battery with plus and minus, and maybe not the best place to put the wire, but so we have a battery, electrons, and let's say this is rectified with a diode. Electrons will go up and up and up until the electron has the maximum amount of potential it can get. So let's think of this as a mountain that is infinitely capable. So electrons can go however far they can. So electrons are constantly being spawned in kind of from the battery and going through, and once it reaches max potential for the circuit, it rolls down, releases all of that potential energy and converts it to kinetic energy. But again, why would we, like, that's just a simple circuit. We can have a circuit like that and it would mean the same thing, but not really any important circuits look like this. That's just a basic circuit, an extremely simple circuit. When we put a resistor in, so we have like a resistor, another resistor, a capacitor, and it goes back. It goes through these resistors and through the capacitor. How can we label this as a potential energy diagram? Well, we can have the mountain again, and we can analogize this with the same wire, but throughout the wire we have these components, such as a resistor for the electrons, another resistor, and a capacitor, and it goes back into the 9-volt battery. Let's just say it's 9 volt. Plus and minus. Electrons are being moved up to maximum potential and being moved down, and essentially where this point starts and this point ends is where we can list all of our components, because when the battery is capable of sending through electrons or electricity, it has reached its max potential, and then as soon as it goes through this wire, goes through these components such as resistors and capacitors and transistors and transformers and inductors, anything you want, no matter how much it affects the electron, the potential for the electron is going down, being converted to kinetic energy and going through the circuit. That is the end of this lesson. I hope you learnt a bit.